Hello everyone, we are going to talk about the vacuum piping system of dry-etch tool. As we talk about the vacuum structure of the dry-etch tool, we are going to talk about it, vacuum piping system, more information with it. This is the typical simple piping figure. This is the wafer, is the E-chuck, and this is the chamber. We have the pump. The first pump and second pump to do the one stage and two stage pumping, and we have the process gas, many kind, just as we talked about before about dry-etch. We use liquid process gas into the gas source assembly. Of course, the important is the argon gas, and let the process gas or argon gas into the chamber depending by the recipe to let in. And of course we have the nitrogen gas. The source pressure, for example, 40 psi high, and the nitrogen often used to purge the piping because it is a very stable gas. Use it. And purge the piping or the vacuum condition we use to. We often use it the maintenance or the manual operation, even the troubleshooting. Use it. And then we have the heating gas, about just 10 psi, maybe little lower, 5 psi. Is using for the process chamber, especially the processing, for cooling, and it's idle gas. It's a very stable gas. For helping the chamber condition stable. So use heating gas to do the cooling and make the chamber condition stable. Of course, there are many valves everywhere, and valves usually controlled by solenoid or electrical. And many valves which we want to know the piping pressure. There are a lot of pressure transducer to know the pressure value. PT everywhere. Pressure sensor. We use the pressure sensor and the valve to control all the piping system. And the process gas, we also have the flow meter to join the control. So many parts. And the piping have to seal the parts completely all the time. It's very difficult. If any parts not sealed very well, the whole system will make tool go down and make the process fail. So make whole system seal is very important. For example, when the system at atmosphere pressure, we are going to start vacuum. The pump second at first vacuum to approach to the 100 millitore. Then and the transducer PT sensor it and then start the pump first to vacuum approach to the 0.1 millitore to be ready. Normal time, the whole system normal operation, it can purge and vacuum in 1 minute to the 0.1 millitore. If you have any operation manually or check or troubleshooting or do a clean purge, it can approach cost 10 minutes to vacuum to 0.1 millitore. After PM maintenance, the whole system remove and restore new one. It costs approach about 1 hour to get the vacuum value to 0.1 millitore. But if the time wait too long. Maybe there is something non-seal well. It's caused a little leak. Gas into the piping. So, depending your experience, the vacuum time take too long, must leak happen, or even cannot vacuum to the set point, must leak serious. For example, the chamber leak rate we set 3 milliliters per minute. 3 milliliters per minute is, for example, different kind of machine has different kind set point. We can calculate that as this. At first, we vacuum to the 0.1 millimeter. Then close the throttle valve. The main valve of the chamber. And make and let chamber sealed. And you can see the PT pressure transducer value 1 minute. If 1 minute increasing above 3 milliliters, it means leak. Condition you cannot accept. You have to do a troubleshooting. That's the calculus simply to verify leak situation. For example, if PT pressure transducer fail, maybe it's supposed to be 0.1 milliliter. It shows 500 torr. It must fail with the pressure transducer. It will cause whole piping interlock. The piping line long and the interlock even to make the pump shut down. So the pressure transducer even shift, not out of control, just shift a little bit, it can cause the piping shutdown. So the pressure transducer, the PT, must prepare new one to renew it at accident happened. Another example, the whole piping, including clamp, screw, and the parts installation position, and the tool fail, the parts fail. For example, the PT pressure transducer or pressure gauge or valve fail. It all can cause the whole piping system vacuum fail. Even after processing some product to cause particle deposition on the surface of the piping, even the process chamber, no clean, can cause vacuum fail. Even more, after maintenance, you clean the parts, the key parts, and a cleaning tool over to let the parts thickness or the parts size shift to be small. That vacuum will fail too. Okay, let's all see you next time.